Hi guys, we're taking a look at this question with some athletes. So we have this diagram below that shows the positions of an athlete at different time intervals during a race. 3.1, they want us to distinguish between motion with uniform velocity and uniformly accelerated motion. So uniform means constant, so it's exactly what it says there. It's motion with constant velocity, and uniformly accelerated motion is motion with constant acceleration. 3.2. What type of motion, meaning motion with uniform velocity or uniformly accelerated motion, is represented by A to B and B to C? So A to B is here. So there is no acceleration. Looks like they're running at the same pace. So there we have motion with uniform velocity. So I'm just going to make that's number 1 and that's number 2. So the answer is here, motion with uniform velocity. 3.2.2, we see B to C. So it's one athlete, right? There he's running constantly, but there he's picking up the pace. But he's running at a uniform acceleration. So there we have uniformly accelerated motion. Okay. 3.3. Use the information in the diagram to draw an accurate. When they say accurate, they want coordinates, guys. You have to have coordinates. They want a position versus time graph. Position versus time graph means position is on the y-axis and time is on the x-axis. Okay, so let's draw that graph. So we are going to work in intervals of whatever is given here at the top. This will be the time, and this will be the position. Okay, I'll do it on the next page. Sorry for my skew line, guys, but it has to just use a ruler. Don't be like me. So time is on the x-axis, and that's going to be seconds. Please remember the seconds. And position will be on the y-axis, and please remember the meters. And your 0. Okay, so let's have 1.5 here. I'm just going to copy whatever the table has given me. Okay, then we count in 5 here. Okay, something like that. Okay. So if we go back, the time was 1.5. Well, it would be 1.5 and 3 meters. So somewhere here we have 1.5 and 3 meters, somewhere there. Then we have 3 seconds and 6 meters. So somewhere on top of the 5 is 6. This is not accurate, guys. Like my graph is not accurate. Please draw some nice lines. You will have graph paper, so it will be a bit easier for you. 4.5 is 12 meters. So it's a bit above the 10 down. So it's somewhere here. 6 is 21 meters. So it's a bit above there. All the way across, somewhere there. And 7.5 is 33 meters. So it's up there somewhere. All the way up there. So let's say somewhere there. I'm just going to pretend like it's there, right? So then you have to connect the line. I'm going to draw very slow. Okay. It's going to be something like that, right? It's going to look a bit better. You're going to have to draw some straight lines. Remember, this is not a curved line. This is straight lines. You're going to take your ruler and draw a straight line from 0 to 1.5. Draw a straight line from 1.5 to 3. Draw a straight line, not my curved lines. Just draw straight lines. Take your ruler and draw a straight line from every coordinate you see. You don't have to connect it like this. I'm just going to show you. You don't have to connect it like this. Take your ruler and connect point 1. Take your ruler and connect that point. Take your ruler, something like that. All right. So it has to look something like this. Then 3.4. Define the term instantaneous velocity in words. So instantaneous velocity is a rate of change in position, or whatever your textbook tells you. Velocity at a particular time, whatever the case might be. 3.5. On the graph that you have drawn in 3.3, show how you would determine the instantaneous velocity. So how do we determine the instantaneous velocity? That is just the tangent to the curve. So your graph would have had a nice curve. Somewhere here would have been the curve. If you had if you drew a nice line, then you would just draw a straight tangent all the way up, and you would get that correct. 3.6. Calculate the velocity of the athlete at 3 seconds. So what do we have? We have 3 seconds there, and we know that 3 seconds is 6 meters. So what we have time and we have distance. So we only need velocity, so we can again use our nice formula there. We can manipulate it to make velocity the unknown. So velocity equals to distance over time. So distance we have at 3 seconds is 6 meters, and the time is 3 seconds, and that gives me 2 meters per second to the right. And that's it, guys. See ya.